right, so in the third part of this video on introduction to Markov chains, we're going to be looking at a distribution of states. So in our previous example, we talked about probabilities of transitioning from one class to the other, depending on if you were lower class, middle class, upper class. So in this example, what we're going to look at now is we're going to look at what happens if we already know the proportion of the population that is in each class. So for example, in here, we know that the proportion of the population that is lower class is 21%. The proportion of what is considered middle class is 68%. And the proportion of the upper class is 11%. Okay? So here, what we could do is we could use this idea of the transition matrix to help us determine what would be the proportion or the probability of this initial distribution as we transition from one state to the next, okay? So in order to do that, what we're going to do is we're going to write what's called a probability vector. So we're going to write what's called a probability vector. So the probability vector is essentially a one-row vector of each of these proportions. It only has one row, okay? So that probability vector we will usually label as x of O. So I'm just going to basically take each of these, write them as a decimal, and write them in a row. So the probability vector for this initial distribution would be 0.21, 0.68, and 0.11. So now the question is, okay, so here's my initial distribution. What would be the probability as we transition from one distribution to the next? Okay? So here, to calculate that, we would do x of O times p. So we would do our 0.21 times 0.68 times, or not times, 0.11, that probability vector, times the matrix that we had from before, so 0.65, 0.28, 0.007, 0.15, 0.0 or 0.67, 0.18, 0.12. I'll actually wrote those out right. 0.36 and 0.52. Okay, so we're going to multiply these together. So again, remember that in order to multiply matrices, the number of columns here has to equal the number of rows, which they do, 3 and 3. This is a 3 by 1, or this is a 1 by 3, this is a 3 by 3. So our answer is essentially going to be a 1 by 3. So again, we take each entry in the here, multiply it by each entry in the column, and then add those together. So when I multiply those together, we get 0.2517, 0.5540, and 0.1943. So what does that tell us? Well, that tells us that if we started with this initial distribution of the population for each of the classes, and we transition using these probabilities, that means that the proportion of lower class in the next is going to be 0.2517. The proportion of middle class is going to be 0.5540, and the proportion of upper class is going to be 0.1943. Okay? So in another example, let's say they say find the distribution of income classes after 2 generations. Okay? So this time they want us to use n equals 2. So in this case, we would use x of O times p squared. So again, keep in mind that our probability vector was 0.21, 0.68, and 0.11 times, this time we're going to use p squared from the previous example in the previous video. So we calculated p squared to be 0.4729, 0.3948, and 0.1323 for row 1. Row 2 was 0.2196, 0.5557, 0.2247, 0.1944, 0.4620, and 0.3436. Okay, so again, 1 by 3, 3 by 3. Notice that the number of columns matches the number of rows, therefore we can multiply these two matrices together. So when we multiply these two matrices together, we're going to get a 1 by 3 answer. And the 1 by 3 answer that we get is 0.2700, 0.5116, and 0.2184. So if we start with this distribution initially, and we use this transition matrix for 2 generations, the probabilities, we would get that the distribution of income classes after 2 generations would be 0.2700 for lower, 0.5116 for middle, and 0.2184 for the upper. Okay. So, again, as always, this brings us to the end of talking about Intro to Markov Chains. So in the next set of videos coming up, we're going to be talking about regular Markov chains. So again, as always, if you have any questions, feel free to send me an email, ask your questions there, or ask to set up a Google Meet, and we will get that done for you. All right, until next time, we will talk to you later. Have a great day.